Hello guys, welcome to ERID Academy. JAMB 2018 Chemistry, full solution and simplified explanation. We're going to consider question 1 to 5 in this particular video. If you have not subscribed to this channel, make sure you subscribe and share with your friends. Let's consider question 1. The periodic classification of the elements is an arrangement of the element in order of their A, atomic weight, isotopic weight, molecular weight, and D, atomic number. So this question tests your understanding of the basis on which the elements in the periodic tables are arranged. So basically, if you consider the periodic table, elements in the periodic table are arranged in order of increasing atomic number. Let's look at period 2. The first element here has an atomic number of 3. That's lithium. The second element is beryllium with an atomic number of 4. Okay, still on this period. The third element has an atomic number of 5. The fourth element has an atomic number of 6, and that is carbon. The next element, which is the fifth element in group 5 of the periodic table, period 2, group 5 of the periodic table, that's nitrogen, okay, has an atomic number of 7. So the atomic number, progresses to oxygen 8 and to fluorine 9 and to neon 10. You can see there is a graduation, increasing graduation in terms of what? Atomic number. So let's consider the question again and apply this knowledge. If you look at this particular, option that you have here, you have isotopic weight, which will not be any near the correct answer. You can use the principle of elimination here. Isotopic weight, not all elements exhibit isotopy. So elements in a periodic table could not have been arranged in order of isotopic weight. Then molecular weight. Elements in the periodic table, okay, are not, they exist as atoms. So the periodic table represents the atoms of elements, not molecules of elements. So we have oxygen, not O2, represented in the periodic table. So why the atomic number of oxygen is 8 and the atomic mass of oxygen is 16, okay, the molecular mass of oxygen will be what? Will be 32. So these two, B and C, are totally off the radar. So you are left with atomic weight and what? Atomic number. So the appropriate response to this question is that elements are arranged in order of increasing atomic number. So it is just by coincidence that, of course, if elements are arranged in order of increasing atomic number, definitely the atomic weight will also increase accordingly. For example, you would expect that neon will have a higher atomic mass than what? Than fluorine. Fluorine will have a higher atomic mass than oxygen, and it's just a general expectation. Okay, so the elements are arranged in the periodic table in order of increasing atomic number. And so the correct answer here is what? Is D. D is the correct answer. So number 2, quickly. If 1 liter of 2.2 mole sulfuric acid is poured into a bucket containing 10 liters of water and the resulting solution mixed thoroughly, the resulting sulfuric acid concentration will be what? So this particular question is based on what we call the principle of mixture, or if you like, okay, dilution what? Dilution, principle or dilution factor. So if you have to calculate the concentration of the resulting solution, it's pretty simple. All you have to do is, to do the ratio of concentration, okay, multiplied by volume. So we can have concentration, initial concentration, multiplied by initial volume, okay, should be equals to concentration, next concentration, multiplied by the resulting volume. That's your final volume. This is so because we would expect that if no additional quantity of sulfuric acid is added to this particular solution, the number of moles of sulfuric acid before dilution should be equal to the number of moles of sulfuric acid after dilution. And of course, we know the formula for number of moles to be concentration times volume in what? In dmq. So therefore, N1 should be equal to what? N2. If no additional sulfuric acid, was added to this particular solution while preparing the solution. So we would expect that we use this formula for our what? Calculation. C1 V1 equals to what? C2 V2. So what is our C1 here and V1? So we have our C1 here is 2.2 mole and our V1 is 1 liter. Okay, and 1 liter is 1 dmq because 1 liter equals to what? 1000 mil, which is equals to 1000 cm3, which is also equals to what? 1 dmq. Okay, so our C2 is what we are looking for. Our V2, how do we get V2? Which is your final what? Volume. Your final volume will be the initial volume V1 plus additional distilled water added to this. Okay, additional what? Additional water added. So we have 1 dmq, which is 1 liter, plus 10 liter. Say 10 liters. That is your 10 what? Dmq. So we have 11 dmq. So let's make C2 the subject of the formula. If you have C1 V1 equals to C2 V2, therefore C2 will be equal to C1 V1 over what? V2. And what do we have? We have C1 2.2 multiplied by 1 over 11. And so that value will be equals to 2.2 multiplied by 1 divided by 11. So that should give us 0.2 molar. 0.2 molar. So let's check our option. Okay, the closest option here is 0.22 molar. And so the correct, answer here is what? Is C. C is the correct answer. So number 3. In the above experiment, the litmus paper will initially A, be bleached, turn to green, turn to red, turn to blue. Now, to answer this question correctly, you will need some basic principle. You will need to remember the effect of acid, okay, and base or alkaline on litmus. So quickly, acid acts on litmus. It changes, neutral litmus to what? To red. Blue litmus to red. If your base acts on your litmus, it will convert your red litmus paper to blue and your neutral litmus paper, which is purple, to what? Which is, pink, in color, and it changes that to what? Changes that to, blue or indigo, or violet, but basically, blue. So the next theoretical background that we need to solve this question is the effect of mass on diffusion of gases. Okay, effect of mass on diffusion of gases. That is the second thing. You need to remember your understanding of what? Of the diffusion of what? Of gases. Increase in mass reduces the rate of diffusion of gas. As the mass of the gas increases, the rate of diffusion of the gas will reduce. So that tells us that a lighter gas will diffuse faster than a heavier gas. So the third theoretical knowledge you need to solve this problem is your knowledge of thermal decomposition. Okay, so the substance that is being heated here is solid ammonium chloride. When solid ammonium chloride is thermally decomposed, of course, you know thermal decomposition has to do with the breakdown of of a compound into its various components using the energy of heat. So when ammonium chloride is heated, ammonium chloride breaks down into ammonia gas and hydrogen chloride gas. Okay, so when this happens, you also need to look at your product. The product, we have two products here. One is a base. Of course, ammonia is the only alkaline gas. Okay, while hydrogen chloride gas is an acid. Hydrogen chloride gas is an acid or acidic. Okay, and of course, if we go back to the question here, studying the diagram properly, we have an asbestos here. Okay, it's a porous asbestos. That simply means that when your ammonium chloride breaks down, the gases can proceed here and they can pass through the asbestos. But here we have a damp litmus paper. Yeah, you will agree or you will remember that for your gases to become acidic, they have to dissolve in water, and that is why hydrogen chloride gas is known as an acid anhydride. You need to remember that. Acid anhydride. These are gases, okay, that dissolve in water to form acid. Example of your SO2, okay, these are acid and acid anhydride, carbon dioxide. For example, your SO2, okay, or SO3 can dissolve in water to form sulfuric acid. If you recall the formation of acid rain. So these gases are called acid anhydride. The same thing, ammonia is a base anhydride. Ammonia can dissolve in water to form ammonium hydroxide, which is a base. And ammonium hydroxide will turn litmus paper blue, while hydrogen chloride gas will turn neutral litmus paper red. Now, how do we apply this knowledge to solve this particular problem? If you get back here, the question now is not just about whether the litmus paper will turn green or red. The question here, the focus is the litmus paper will initially, this is the key word here, initially turn what? So the first gas to diffuse to the damp litmus paper will form a particular color with the litmus. So here we need to consider the two gases diffusing. Which one is the lighter gas? The lighter of the two gases will be the one to react first with the litmus paper. So let's calculate the molecular mass of these gases for us to be able to determine which one is the lighter gas. I want to believe that you can remember how to calculate the molecular mass of your compound. So to calculate the molecular mass of compounds, you need to add all the relative atomic masses of the constituent element. So we have your nitrogen, which is 14, plus hydrogen, which is 1. So we have 3 of them. So everything is 17 grams. So we have hydrogen chloride gas, which is hydrogen is 1, chlorine is 35.5. So we have 36.5 grams. Obviously, you can see that your nitrogen will be the lighter the lighter gas. That tells you nitrogen will diffuse faster than hydrogen chloride gas. So if ammonia would diffuse faster than the hydrogen chloride gas. So if ammonia gets to the damp neutral litmus paper, it's going to convert it to blue. So the correct answer here is D, because litmus paper turns blue when it comes into contact with with base or alkaline. That is pretty interesting and pretty simple. So let's look at this question 4. A correct electrochemical series can be obtained from potassium, sodium, calcium, and they listed the electrochemical reactivity series here. Okay, so they ask us the question, if we have to do an interchange between any of the metal in this arrangement, which one will it be? So basically, this is just a recall question. You should be able to recall your reactivity series from your potassium, okay, down to your silver, to your platinum. Okay, so if you check this, potassium, sodium, calcium, now something is not correct around here. I want you to be able to recall what we call the marxit metal. These are metals that are used in the preparation of what? Of salt, especially when you want to react metal plus acid to prepare salt. You will not want to prepare your salt reacting sodium plus acid. That is going to be an extremely explosive reaction. So we'll use what we call the marxit metal. So remembering the acronym marxit, we can help you actually or quickly recall the correct order of the arrangement of elements in the electrochemical series. So this stands for your magnesium, and this stands for your aluminium. This stands for your zinc. Okay, this is your iron, and of course this is your what? Your tin. So let's look at this particular arrangement. You can see here magnesium should come before aluminium, but we have aluminium coming before magnesium. So we need to rearrange this particular two elements here. So the correct answer here is what? Is A. Magnesium should come before aluminium. So by interchanging that, the electrochemical series as represented here will be correct. Fantastic. Well done for making this progress. So let's look at the last question in this series, which is question 5. Question 5 says, a basic postulate of the kinetic theory of gases is that the molecules of a gas move in straight lines between collisions. So basically, for you to be able to answer this question, you need to be able to recall, your understanding of kinetic, theory of gases, and of course the ideal gas law, what the ideal gas law says, or the assumption of the ideal gas. So let me quickly remind you of this basic assumption. So the kinetic theory of gases assume some 5 basic things about ideal gas molecules. Number 1, you need to recall that the gases are in state of continuous motion. They are moving randomly, and the volume of the gas could be negligible, and they have negligible intermolecular forces, and this also include both force of attraction and force of repulsion. Okay, so and ideal gas undergo perfectly elastic collision. There is a perfectly elastic collision between molecules of ideal gas, and of course the average kinetic energy is proportional to the absolute temperature of the ideal gas. So what is the implication of this relative to this question? So you also need to be able to recall that an ideal gas is defined as one in which all the collisions between the atoms, the molecules, collisions between the particles are perfectly elastic, and of course there is no intermolecular force of attraction between the particles. So when we say that collision is perfectly elastic, that simply means that the particle can bounce off each other when they collide, and of course if they can bounce off each other, it means that the collision does not consume energy. So how do we know that collisions between an ideal gas do not consume energy? The temperature of the gas remains the same even as they collide. There is no change in temperature. Okay, so we say that the collision is perfectly elastic. So based on this, you should be able to guess the correct answer to this question. So the forces of repulsion does not exist between the particle. Force of repulsion and attraction and in equilibrium, that will not be the correct answer. The correct answer here is that the collisions are perfectly elastic. Okay, so if you have not subscribed to this channel, kindly subscribe and share with your friends, and also click the notification icon so that when I draw fantastic videos like this, you'll be the first to be notified. I'll see you in the next series.